first of all, Murphy, say hi, Murphy. Say hi, Ava. All right, so those are my dogs. All right, we are working on section 2.3, and we're going to deal with number 18. And we're going to deal with number 18 two ways. We're going to deal with it using the addition elimination technique. We're also going to deal with it using the substitution technique. And the first thing that we need to do is to define our variables well. So we're going to describe X as the amount of dollars invested at 15%. And if that's the case, because in the problem we're told we have $50,000 to distribute to two accounts, our second account, Y, is going to be equal to 50,000 minus X. So if we had, $20,000 here, we'd have $30,000 in this account, because 50,000 minus 20,000 is 30,000. It's always important to try and set up your variables so they make good sense. All right. So we can take this equation, the 50,000 minus X equals Y, and we can write it in an alternative form by adding X onto both sides. We can write it as X plus Y is equal to 50,000. And the reason that I did that is because we have a restriction equation, which is telling us that we've got to get $6,000 out of our interest. Well, the way that you determine interest on an account is you take the rate, and one of the rates was 15%, and you multiply it by the number of dollars in the account. And then you add to that the interest earned into the second account. And the way you determine that is the rate multiplied by the amount of dollars in that account. Hopefully that makes sense. So now what we'll do is we'll take this equation, and we need to get one of the variables to have the same numerical coefficient, but we need them to be opposites. So what I've chosen to do is to get my y's to be the same numerical value, but one is positive and one is negative. And the way I'm going to do that is I'm going to multiply this entire equation by negative 7. So it'll become negative 7x minus 7y is equal to a negative 350,000. Adding like terms, I'm left with 8x, because 15x minus 7x, and these two eliminate, is equal to 600,000 minus 350,000. I'm left with 250,000. We're going to divide both sides by 8. So our x turns out to be 31,250. Now, according to our setup, our y is 50,000 minus the 31,250, which gives me 18,750. Oops, my apologies. 18,750. Okay. Now, what if we were going to do this using the substitution technique? Well, we were, when we designed the initial setup, we moved the equation 50,000 minus x equals y around so that the x's lined up, the y's lined up, the equal signs lined up, the plain numbers lined up, so that I could do the addition elimination technique. With the substitution technique, I just need to have one of the variables solved for, and I have one of the variables solved for in this expression, or in this equation, forgive me, and what I'm going to do is I'm going to take that and plug it in place of the y, because y is equal to that expression. So what ends up happening is I replace the y, I give the boot to the y gets thrown aside, and I replace it with the expression that contains the x. So I now have 15x plus 7 times 50,000 minus x is equal to 600,000. I should make a comment that I started with 15x plus 7y is equal to 600,000, rather than the 0.15x plus 0.07y is equal to 6,000. I multiplied everything through by 100. So now, I've got the 15x. 7 times 50,000 is 350,000. 7 times x is negative 7x. And I still have my 600,000. So I'm going to subtract 350,000 and subtract 350,000. And I get 15x minus 7x is 8x. And then I get my 250,000. I'll divide by 8, divide by 8, and the process fits what happened up here. Hopefully that's helpful.